This video is a companion video to the other video that I have on quadratics. So watch that one first and then watch this one. This one's all about the applications of quadratic functions. When you see the word applications in math, you should think word problems because that's what we're going to be doing today. Now, conceptually, right, what are the two things we ever are like looking for when in a quadratic that we've been talking about? It's either the vertex, like the coordinates of the vertex, or the x-intercept, so like where it crosses the x-axis. So we have various ways to find these things, right? For a vertex, we know that the vertex is at negative b uh, over 2a, comma f of negative b over 2a. So that's what the coordinates of the vertex. We also know that x-intercepts are like, if you get a function into this form, the x-intercepts will be, oh no, that's wrong. Sorry, x minus n and x minus m. The x-intercepts will be at n and m, xi's of n and m. Or, if you do the quadratic formula or you complete the square and solve for x, you'll find where the x-intercepts are. So straightforward ways to find these two pieces of information. The complicated part, of course, as is the case with any word problem, is interpreting the problem and thinking about what it's going to say. So I'm going to give you some tips and tricks, and we'll go through quite a few problems here in this video that covers that. So here's a problem, and this one has to do with finding maximums. The sum of two numbers is 52. Find the maximum of the product of the two numbers. Well, if the sum of two numbers is 52, I'm going to let x equal the first number. And if they add up to 52, that means 52 minus x has to be the second number. So if the sum of two numbers is 52, we have accounted for that just by defining the variables. We want to know what their maximum product is. So product is multiplication. So essentially we have a product as a function of x, right? We're multiplying two numbers together. So I want to find the maximum of this. This maximum corresponds to a vertex, so we'll have 52x minus x squared. If you were to graph this, if you don't know what this would look like graphed, you'd have something like, let's see, you'd have something like, let's see, 152, like do something like this as you're multiplying the numbers. So we're going to be looking for this, right? This is going to be a maximum. How do we find the maximum? Again, it's negative b over 2a, right? So the issue is this isn't in the right form, so we got to put this in the right form. Negative x squared plus 52x. There's like a plus 0 over here, right? But we're not going to put that. Okay, so now we just do negative b over 2a, or you could put this into vertex form to get the hk off of that. But we'll do negative b over 2a because it's super straightforward. Negative b over 2a is equal to negative 52 divided by 2 times negative 1. So basically 52 divided by 2, it's 26. So one of my numbers is 26, and the other number is 52 minus 26, which is 26, right? Which this should make sense to you. If you're multiplying two numbers together, the maximum is like a square. Think about a rectangle, right? What's the maximum area of a rectangle? It's when that rectangle is a square. So the two numbers are 26 and 26 for this problem. Um, you could also find out, oh wait, actually, so we know what the maximum product, we were actually looking, we found x, we want the maximum product. What is the maximum product? It's 26 squared, which is some number. That number is, I'm just going to do this in my head real quick. I'm definitely not typing this in a calculator. 676 would be your maximum of maximum product. Okay, so that's how you would find it. There's also the case where we want to find the maximum that involves height. And this is really a very similar problem. And if you're not familiar with what this is here, this is the equation for the horizontal part of projectile motion. If you've taken physics before, the 16 represents um, half of acceleration due to gravity in the English imperial units in feet per second squared, and then 800 in this case is my 800 feet per second. It's initial velocity. Anyway, this is how you would find the maximum height. Okay, I want the maximum of h of t is a height with respect to time and seconds. So after how many seconds, we could either find after how many seconds that there will be a maximum height, or we plug that seconds in to get what the maximum height is. So you can imagine what like the graph of height over time of something shot off the ground. It would go up really high, and then it would eventually come down due to gravity. So we want to find this. In order to find this, we're going to want to find this t value, and then we'll plug this t value back in to find this h value, right? Whatever h of t is right there. Now we can do this. I'll do this one in two different ways. We'll do it just like the previous problem where h of t is equal to, we'll just rearrange this real quick, negative 16t squared plus 800t plus 0. A is, well, let's do negative b over 2a, right? Negative b over 2a is negative 800 divided by 2 times negative 16, which is just 800 divided by 32, which is some number. I'm going to do this one in my head also. I feel like it's probably 20. No, it's not. It's 30, right? It's 50. That's what I said. It's 25, isn't it? Uh, yes, it's 25. Okay, so 25. Sorry. So after 25, like 25 is my maximum, is the x coordinate of my maximum, and my x values here are time values. So after 25 seconds, this bullet reaches a maximum. I want to plug this 25 back in to find what that height would be. So it's literally h of 25. That would be negative 16 times 25 squared plus 800 times 25. No idea what this is, so I'm going to have to do it in my head again. 25 squared is 625 times negative 16. Let me think about that real quick. Yeah, of course it's negative 10,000. But then we need to add 800 times 25, which is going to give me positive 10,000, because 800 times 25 is obviously 20,000. So what does this equal? It's 10,000 feet. That's how high that balloon will go, which is not quite which is not quite 2 miles, but it's close to it. So that's pretty cool. That's the maximum height, is 1,000 feet. Max height 10,000 feet. I said 1,000, 10,000 feet. That's pretty cool. Okay, let's look at a more complicated problem now. And these are, from being a math teacher, I can tell you from experience that these problems here really throw students for a loop. And it all comes down to the concept of revenue. Okay, what does that mean? Well, at the very simple, in a very simple definition of revenue is, it's the product. Like, think about if you're selling a product, right? How much money are you making? Well, you're gonna make like however much, like the cost of the product, like how much you charge for it, times the number sold, right? So if it's tickets, it's the price of a ticket times the number of tickets you sold. That's your revenue, right? If it's a subscription for something, how many subscribers do you have times how much are you charging for a subscription? Just at a very basic level, okay? So anytime we have a revenue problem like this, we have to think about, okay, what's the price and how many are we selling? So in this problem, it says Mr. Schmidt is giving juggling lessons. He currently has 16 customers and charges $21 per session. He has found that for every $1.50 increase in price, one customer leaves. What should he charge in order to make the money? In order to make the most money? So we're gonna say X is number of $1.50 price drops. Okay. And keep in mind that that number $1.50 price drops is the same number as a number of customers that are leaving. Okay, so let's think about this. Revenue is equal to cost times, in this case, he's got customers, right? Number of customers. So what does he charge? $21 per session, and he's got how many customers? So we're going to say revenue as a function of X, because we use X as our variable. How do we describe the cost here? It costs $21, but he's going to be increasing the price by $1.50, some number of times X, right? So plus 1.5X. That is representing the cost that he's selling these things for. Now, how many customers does he have? Well, he starts with 16, but every time he does this price increase, he's going to lose one customer, so 1X, or just X. That's it, right? Now I have this thing. It's obviously going to be a quadratic after I multiply this out. And we can use our knowledge of how to find the vertex um, of a parabola uh, to find the maximum here. Because the maximum, like think about this, right? It's always a good idea to visualize what's happening. He's selling, he's making some amount of money. He's gonna every time he's gonna this is gonna be like increases in price, and this is gonna be his revenue. Revenue as a function of x. Okay, so I'll try to write x upside down there. It's going to do something like this. Eventually, he's going to start charging so much that he's not going to have enough customers and he's going to be making less money. But after some number of customers, he's going to have an ideal situation where he's maximizing the amount of money that's coming in. So that's what we're trying to find here, right? It's a maximum. So we just multiply this stuff out. We're going to have 21 times 16 is 336. Right? 21 times negative x is negative 21x. 16 times 1.5 is 24x. 1.5x. 1.5x, 24x. And then 1.5x times negative x is negative 1.5x squared. Okay, so it's a quadratic. So let's simplify this and rearrange it. We're going to have negative 1.5x squared. Negative 21x and 24x is positive 3x. And then plus 336. So what we want to do is find the coordinates essentially of the maximum, which is the vertex. So it's negative b over 2a, which is negative 3 divided by 2 times negative 1.5, which is going to be 2. Right? Oh, it's 1. Sorry, it's 1. I can do math. That's just positive 1, which this means that he just needs to change his price by adding $1.50 one time. So his total charge is going to be, he should charge $22.50, right? We can take this one and plug it back into our expression for cost to find out what he should charge what he should charge to maximize profit. So it's going to be, this is the answer. He should charge what is she 21 plus 1.5. He should charge $22.50 per session. That way he'll have 15 customers, right? So what will his revenue be at that stage if you wanted to know that? Because the question could ask you that also. Well, then it would be you just plug this one back into each of these things and multiply it out. It'd be 21 plus 1.5 times 1, right? This is going to be essentially R of 1 at this point. Okay, times 16 minus 1. So it's 22.5 times 15, right? 22.5 times 15. His maximum revenue that he'll be making after that would be $337.50, which is pretty good money there. Good job, Mr. Schmidt. And for comparison, like 21 times 16 is $336, right? So he wouldn't be making like a ton more than he's already making. He's doing pretty well for himself. But if he increases price by just $1.50, he could be maximizing his revenue. What would it be like? Let's think about what it would be if he changed it 3 times just to prove this, right? What would R of 3 be? Well, then I'd have 21 plus 450, right? So 2550. Oops, I did that wrong. 25.5 times, and if it was 3 times, if he changes cost by $1.53 times, he would lose 3 customers. So times 13, that would be $331.50. So he's going to keep going down if he adds more money. So he should charge $22.50 to maximize his revenue. Actually, before we do this one, I promised I would do this other one in 2 different ways. So let's just go back and do that to illustrate. The other way to do this one, besides negative b over 2a, is to complete the square and get this thing in vertex form. So we're going to get this equation in vertex form, this function. And to do that, we would say it's negative 16 times t squared, and then 800 divided by 16 is 20. No, it's not. Sorry, 800 divided by 16 is 50. All right, so t squared plus, no, it's going to be minus because we're taking out a negative 16. Minus 50t, leave some space, and then we're gonna have to complete the square inside here. So it's what is 50? So hold on a second. We've got what is half of 50? It's 25. Squared is 625. We have to subtract. We added, so what did we do here? We added 625 inside the parentheses. We multiplied that by negative 16. So 625 times 16, oops, sorry, 625 times 16 is 10,000. But we added 10,000. So we added 625 on the inside, multiplied it by negative 16. So we really subtracted 10,000. So to balance it, we have to add 10,000. And then we'll have this negative 16 times t minus 25 quantity squared plus 10,000. So here in vertex form of this equation, this original equation, height, this function height as a function of time, we see that our vertex is 25 and 10,000. So either way, it works the same way. It gives the same answer. Okay, this one here is particularly difficult, right? You just have to, again, think of this. Revenue is equal to cost times number sold. Number sold. Okay, so a manufacturer finds that for the first 500 units of its product that are produced and sold, the profit is $50 per unit. The profit on each of the units beyond the 500 is decreased by 0.1 times the number of additional units sold. So number of additional units sold, we need to find that in order to find a maximum here. So let's say X equals number of, my pen's not working very well here, number of units sold after 500. Okay, so let's set up our function as our revenue function here. Revenue as a function of X. Okay, first of all, they are going to make $50 per unit for the first 500 units, and then after that is when we start changing things. So it is guaranteed that 500 times 15, because they're charging 15, or sorry, not 15, 50. 500 times 50 is their revenue that they're going to make just straight up on the first 500 units. Now after that, right, we're going to add some more revenue, and we're going to again say the number sold, which is X, times what's the cost now, or like what's the cost, how much profit are they making on each of these additional units. Well, they are going to be they're going to get 10 cents less per unit, right? Like each time they increase the number of units, they'll not make 10 cents or whatever. Hopefully that makes sense. So they started with 50. They're usually making 50 per unit, but each time they're going to lose 0.10x, right? 10 cents. So this is it, right? That's what this is saying. Okay, now think about what this means. Because this here is you're already making it, and then this here is going to be kind of like your parabola. This is going to be a quadratic that has a maximum on it. Now graphically, we can actually write this in. Okay, if we say 500 times 50 plus x times 50 minus 1.1x, right? Point 0.1x, right? We're gonna have a graph here. I gotta zoom out a lot on it. It's gonna be pretty big numbers. So we have this parabola, right? We're talking extreme, like very large amounts of money. And if I click here, it tells me this number here. Now, what are these values? Well, 50 times 500 is $25,000. Okay, that's how much money they're making on those first 500 units, and that's what we have here on our y-intercept. So that's like where this all started. The stuff to the left of the y-axis is not relevant to this problem. Okay. Now, as they sell more units, yeah, they're going to make more money, but eventually they're going to start making such little money that they will no longer, they will be losing money. So then they're going to start losing their money. So they would never want to sell, anything beyond their ideal amount is to add an extra 250 units of production here. Because if we started with our original 500, this is all about additional units. Remember what we called X. So going back to what we were looking at, if we solve this, like we already know just from looking at the graph that it'd be 250, but we can still do this. So this is going to be 25,000 plus 50x minus uh, 0.1x squared, and we're just going to do the negative b over 2a here. So actually, let's rearrange it first. Negative 0.1x squared plus 50x plus 25,000. Okay. Negative b over 2a means that we'll have negative 50 divided by 2 times negative 0.1, so negative 0.2, which is going to give me, what does that give me? You said it's 250, right? This is equal to 250. So that means an X was the number of units sold after 500. So what level of output would maximize profit? Original 500 units. Oh, my pen's not working well here. Plus the new 250. That's your 750 units. And then you can plug 750 back into this function here to find out how much money they would then be making. But we know what that is already because of what we had on the graph. It's actually $31,250 they would be making, which is pretty good, right? So this is revenue is equal cost times the number of units sold, and you apply that idea, specifically to a problem. Okay, and then lastly here, we're going to look at one that is similar to the bullet problem, but this one says the function h of t is equal to negative 16t squared plus 40t plus 50 describes the height of a ball that was kicked off of a cliff as it heads towards the ground. How long will the ball be in the air for? So again, from physics, negative 16 here is half of the acceleration due to gravity in feet per second. 40, this isn't really important, but 40 represents the initial velocity, the initial upward velocity, and then 50 is actually representing the initial height of this object, which is a ball. Okay, so how do we, that's all really not that important. What we want to do is find how long the ball was in the air for. Just to draw a graph here to illustrate what's happening, okay, we have a ball that was kicked off of a cliff that's like 50 feet high. This is height. The y-axis is height. Okay, it's going to go up a bit, and then it's going to come down. And time is along the x-axis here, so or the horizontal axis. So we want to know what is this t value here. So that's all we're gonna do is we know how to find zeros for for something like this. So how do we do it? Well, actually, I don't know if there's an easy way to do this one. So we'll just we can use the quadratic formula for this. So t is gonna equal, and we have right. What is b? What is a is equal to negative 16. Okay, b is equal to 40, and c is equal to 50. Yeah, you can actually divide everything by 2 here to make this, if we divided this equation by 2, we'd have a similar equation where you have the same roots. So we could say negative 8t squared, sorry, plus 40t, no, plus 20t, sorry, we're dividing by 2. 20t plus 25. So now, what are a, b, and c? A is negative 8, b is 20, and c is 25. So we can plug this into the quadratic formula. Negative b would give me negative 20 plus or minus the square root of, and just, any way you want to solve for roots here. If you could factor this, then you could factor it. If not, then you could use completing the square of the quadratic formula. 20 squared, b squared, minus 4 times a, which is negative 8, times c, which is 25, and that is all over 2a. Okay, now, you can think about this because we know, first of all, if we have a negative times a negative in our 4ac term and under discriminant, we're going to add that to 20 squared, which is 400. So we'll have a square root of a positive number. So we have in the numerator of this, we'll have negative 20 plus a positive number or negative 20 minus a positive number. Recognize that it can't be negative 20 minus a positive number. what that would be giving us, that minus version of the answer would be giving us whatever this theoretical time is here, which has zero relevance to our problem because time equals zero is when this all started. We can't have like a negative time here. So we don't even have to consider the minus version of the quadratic formula. So really what we're trying to find then is the root that's positive. We're looking for the positive root. So how do we do that? Well, just just do the math that's involved here. So I'm just going to type this into a calculator really quickly, and I'll give you what the two answers are. So A, we said was -8. B, we said it was 20, and C, we said it was 25. So our two answers are going to be 3.415, so 3.42 was 3.45 seconds, and the other answer is going to be negative 0.915 seconds, which that one doesn't make sense, right? It can't be negative. So it's at 3.415 seconds is when that ball is going to hit the ground. And so we can say then that's what it's saying. The ball will be in the air for 3.415 seconds. So this is the last, that's it. That is using our ability to find the vertex and the zeros of a quadratic to solve application problems.